Hi, and welcome to another video lesson in physical science for grade 11. We are now on the week 3 of this particular semester. This topic will be regarding with intermolecular forces. So ready your note, ready your gadget to take screenshots and to take important details. Once again, I am Sir Feets and welcome to Feets Talks. Here are our objectives for this lesson. First objective is to differentiate intramolecular and intermolecular forces. The second objective is to identify the general types of intermolecular forces. And the last objective is to explain the effect of intermolecular forces on the properties of substances. Before we begin our new topic, let's have a review of our previous topic. So try to remember the following terminologies that I will be showing to you. The first terminology is polar covalent bonding. The second terminology is a non-polar covalent bonding. And the last terminology is molecular geometry. You can write your answer on your notebook or on a clean sheet of paper. You can pause for a while you are answering this particular activity. So let's reveal now the answer to the three terminologies on the review activity. Before we go to the answer, let's have a review regarding with bond polarity. Remember that the polarity of the bonds between atoms can be based to two aspects. The first one is electronegativity and the geometrical shape of the molecule. You can use these two to identify the polarity of the molecules, whether they are nonpolar or polar. So let's have the first terminology, which is the polar covalent bonding. Once again, polar covalent bonding, it means that there is an equal sharing of electrons. Remember the term, an equal sharing of electrons during the process of polarity. So example, we have again the carbon tetrafluoride or CF4. We have the two elements, which is carbon and of course fluorine. Identify first the En value or the electronegativity of the two elements. For carbon, you have 2.5 and for fluorine, you have 4.0. After that, you need to find the difference between the two En value of the elements. So 4.0 minus 2.5, that is equals to 1.5. And this 1.5 is what we call now the En value. As you observe, there is an equal sharing of electrons. This separation of charges creates an electric dipole or two poles wherein it's possess a negative and positive pole. Remember that in polar covalent bonding, it is also known as a dipole bonding because it will create two temporary poles, the positive poles and the negative poles. So how to identify the charge of the poles in a dipole bonding? Remember that elements with higher En value become the partial negative pole, while the elements with the lower En value becomes the partial pole. Remember also that a polar molecule is also a dipole. So once again, we have the example carbon tetrafluoride, which composed of carbon and fluorine. On this manner, carbon is the positive pole and fluorine is the negative pole. Why? Because carbon has a 2.5 En value and fluorine has a 4.0 En value. As you observe, 4.0 is greater than 2.5. That's why fluorine is the negative pole and the carbon is the positive pole. The next terminology is the non-polar covalent bonding. In polar covalent bonding, there is an equal sharing of electrons. In non-polar covalent bonding, there is an equal sharing of electrons. Also, you can have this particular factor or the difference between atoms is less than zero point 0.5 is also categorized as non-polar covalent bonding. Let's have an example again. So we have the example of hydrogen molecule, which is composed of two hydrogen atoms. So hydrogen has a En value of 2.1, and once again, transform this one into a mathematical equation and find their difference. So therefore, they will have a zero En value. Therefore, there is an equal sharing because 0 is less than to 0.5. The next terminology is the molecular geometry. Once again, we can determine the molecular geometry of a molecule through valence electron pair repulsion theory or VSEPR theory or VSPR theory. We can identify also through the use of molecular geometry the arrangement of atom at the same time the shape of a molecule. So once again, these are the following or the basic shapes of molecules according to VSPR theory. So you have the linear, the trigonal planar, the bent or angular, tetrahedral, trigonal pyramidal, trigonal bipyramidal, and octahedral. You can take a screenshot of this particular presentation for you to have a reference. This is also an addition to the previous discussion on the basic shapes of molecules. Okay, so take note of this important detail because this is very new from the previous discussion. You must remember this that not all lower En value is a non-polar covalent bonding. It means that if you get an En value of 0, doesn't assure you that it will have a non-polar bonding. It can still be a polar bonding depending to the shape of that particular molecule. So you should always check its molecular geometry to make sure if it is non-polar or polar. So always remember that tip. Let's have this example for you to really understand that not all zero En value is non-polar covalent bonding. So once again, polar covalent bonding is an equal sharing of electrons, while for the polar or non-polar covalent bonding, there is an equal sharing of electron. So let's have an example of phosphine or pH3. So first thing first, you need to identify the En value of phosphorus. So phosphorus and of course hydrogen has En value of 2.1 for phosphorus and 2.1 for hydrogen. If we will conduct the mathematical equation for this to determine the En value, they will have zero En value. Obviously, because it is zero En value, you will assume that this is an equal sharing of electron. But that is not the correct answer. This is not an equal sharing of electron. You need to check their molecular geometry to prove that there is an equal sharing of electron. Let's proceed. So once again, we have the element phosphorus and the element hydrogen. We need to determine now the valence electron of the two elements. Phosphorus has 5 valence electrons and hydrogen has 1 valence electrons. After identifying the valence electron, you need to draw now the Lewis structure of the two atoms. The Lewis structure for phosphorus and for hydrogen. For hydrogen, you will have one dot on the top part of the chemical symbol. While for phosphorus, remember that you will always start putting a dot on the top part of the chemical symbol and moving to the clockwise motion. So if you will put the dots around the chemical symbol, it will look like this. Okay, 1, 2, 3, 4, and then the fifth valence electron. So that will be the structure of phosphorus in Lewis dot notations. So you have phosphorus and of course the three hydrogen. The first hydrogen, the second hydrogen, and the third hydrogen. Remember also that you cannot put hydrogen in different side ways. Always remember that you can put an atom or a sideways if there is a missing electron on that particular side. 'Di ba? Remember, we need to follow the rule of octet or the 8 valence electron. So you have 2 here, another 2, and then another 2. So if you will add all of that, you will have 8 valence electrons. Remember also that you need to complete the 2 electrons on each side so that it will have a balance or stable chemical structure. So now, you need to identify the shape of this particular molecule. So for P, you have the red line, and for hydrogen, you have the blue line. So hydrogen, you have 3 hydrogen, 1, 2, and then 3. So if you will increase the resolution of this particular symbol, you will have this particular shape, the trigonal planar, which is almost similar to a phosphine. Okay? So, yan yung sagot ninyo usually. Magiging trigonal planar, di ba? Pero that is wrong. Okay? So, if we will draw the line of this particular molecule, it will look like this one. The red one is the phosphorus and the blue line is the hydrogen. So this particular symbol is somewhat similar to this one. So this symbol is what we call now as the trigonal pyramidal. So if your answer is this, you are correct. The question is, why phosphine is a polar covalent bonding? So let's have a review again. So you have the trigonal planar and the trigonal pyramidal. So the answer for phosphine, the shape of that is trigonal pyramidal instead of trigonal planar. Okay, let's move on. So once again, this is the Lewis structure of phosphine. The phosphorus as the central atom and the 3 hydrogen as the side atoms. We put the hydrogen on the missing, okay, on the missing dot because this one, originally, the dot on this one is only 1, and this one is 1, and this one is 1. That's why we put the hydrogen on this one para mabuo yung tagdadalawa sa palibot ng isang chemical symbol. So if we will look for pairing or partner, you will have the first partner, the second partner, and the third partner. This particular partner is what we call bonded pair. It is bonded because it is bonded to the phosphorus. Remember, right? So this bonded pair is what we know as the equal sharing. That's why you assume that phosphine is a polar covalent bonding. But remember that on the upper part of the phosphine group, you have the 2 valence electrons here that doesn't have any pair. This particular valence electron that does have no pairing is what we call the lone pair. The lone pair is valence electrons that are not shared with another atom. Therefore, this lone pair make this chemical molecule as a polar covalent. Remember that polar covalent is an equal sharing. So once again, phosphine or PH3 is a trigonal pyramidal at the same time polar covalent. Now we can proceed to our new discussion. These are the terms that you need to remember for our new discussion. You have the term intramolecular and of course the intermolecular. So I think you are ready. Let's dive in. First thing first, what is intra and intermolecular forces? We have two types of forces or interaction. The intramolecular interaction and the intermolecular interaction or force. The term intra in the intramolecular It means within or inside. It means that the forces that keeps binding the atom is inside of it rather than on the outside of it. While for intermolecular, inter means between two groups. It means that it is connecting two individual or two similar things together. So that is the difference between intramolecular and then the intermolecular. But remember, these two are forces of attraction. So this forces binds the atom to another atom or its subatomic particles. So let's have first the intramolecular forces. So intramolecular forces are the forces that binds different atom to another atom. So if you will see on this illustration, this is an example of intramolecular forces. This chemical molecule is H2O or water, wherein because of intramolecular forces, hydrogen atom are attracted to the oxygen atom. So example of intramolecular forces is covalent bonding, which is happening to the H2O molecules. Yes, you have the chemical symbol and of course the Lewis structure, and you have here the intramolecular forces. The next one is the intermolecular forces. Intermolecular forces is the forces that binds molecules to atoms, molecules, or ion. It means that it combines two different atom to each other or two similar atom to each other. So you have here a molecule A and then molecule B combined with intermolecular forces. Good example of this one is, as you can see to the illustration there. So you have two molecules then binded by intermolecular forces. This is also known as the van der Waals forces. Next question is that why intermolecular forces is important? Always remember that because of intermolecular forces, it dictates the physical properties or the chemical properties of a substance, whether the substance will become adhesive, cohesive, or has a viscosity or so and so forth. So that is how intermolecular forces is important. Now, what are the different types of intermolecular forces? We have four main types of intermolecular forces. The first one is what we call ion to ion interaction. The second one is dipole-dipole interaction. And the third one is the hydrogen bonding. And the last one is dispersion forces. We will discuss each of these forces throughout of this presentation. So the first type of interaction is the ion-ion interaction. But before going to this type of interaction, let's define first what is the meaning of ion. Ion is what we called as the particle or atom or molecule with a net of electric charge. So whether it is positive or negative, that is what we called ion. So if we will observe to this particular illustration, you have two types of ions. You have the cation and the anion. Cation is the positively charged, while for the anion, that is the negatively charged. Remember also that cation has more protons than electrons, while anion has more electrons than protons. Let's give some example of those ion to this particular elements. So you have here the positive one, which is the cation, and the negative one, which is the anion. So you have sodium ion. That's why it has a symbol of Na and then the plus sign superscript. And of course, you have the potassium, silver, hydrogen, and so forth. While for anion, you have the fluoride, chloride, bromide, iodide, hydroxide, nitrate, manganate, and so forth. A very good example of ion-ion interaction is the ionic bonding. So you have the two, the covalent bonding and then the ionic bonding. A review lang. What is covalent bonding? Covalent bonding is happening or occur wherein there is a sharing of electrons. While for ionic bonding, there is a transfer of valence electrons between atoms. While in sharing, it means you have share your valence electron to other atom, while for ionic bonding, there is no sharing. There is already a donation of valence electron to another atom. So it generates two positively or oppositely charged ion. Therefore, it produces dipoles. This dipole will create a positive charge or positive pole and the negative poles. So example, we have sodium fluoride or NaF. So if you will have an illustration of this on ionic bonding, it will look like this one. So sodium ion transferred one of its electron to fluoride for it to become valence or in octet rule, as you can see to the illustration. Now, both of them is now on the octet rule upon the transfer of electron of sodium to fluorine. Also, ion-ion interaction is the interaction between oppositely charged ions. It means that there should be an interaction between two opposite poles, the positive and the negative poles. This occurs usually in ionic compounds or ionic bonding. It is also the strongest intermolecular forces, and of course, it follows the principles of opposite attracts. While in the previous discussion, in the polarity of molecules, polar and nonpolar covalent bonding follows the concept like mixes like. It means that if you need to mix two substances to each other, it should be polar and polar or nonpolar and nonpolar. But here in ion-ion interaction, it is already possible to mix or to combine to each other as long as that they are oppositely attracted to each other. So you have here another interpretation of ion-ion interaction. The second type of intermolecular forces is what we call the dipole-dipole interaction. Dipole-dipole interaction occurs between two polar molecules. It means that you have one polar molecule and another polar molecules combining to each other. That's why they form dipole-dipole interaction. Compared to the ion-to-ion interaction, dipole-dipole interaction is weaker by force rather than on the ion-ion interaction. So if you have here an example of illustration for hydrochloric acid, you have here a dipole-dipole interaction. As you can see, to the principle of intermolecular forces, opposite attracts. So you have the positive pole attracting to the negative pole. That's why it calls dipole-dipole interaction. And the third type of intermolecular forces is hydrogen bonding. In hydrogen bonding, it is a type of dipole-dipole interaction. It occurs between polar molecules containing hydrogen. In the dipole-dipole interaction, anything will attract to each other accordingly to the positive and to the negative poles. While for hydrogen bonding, you need an accompany of hydrogen to perform the bonding itself. Compared to dipole-dipole interaction, this is somewhat stronger, okay, rather than to the original dipole-dipole interaction. So you have here an example of water molecules interacting to each other. So you have water molecule 1, 2, 3, 4, 5, and 6. So all of these water molecules have an interaction to each other or forces to each other. So you have here at the center a hydrogen bonding, okay, wherein the positive pole of hydrogen is attracted to the negative pole of the oxygen. Okay, still there is a dipole-dipole interaction. Okay, the fourth type of intermolecular forces is the dispersion forces. Dispersion forces is present in all molecules, but remember that it is the only force present in a non-polar molecules. While for polar molecules, you have the dipole-dipole interaction. It has a very weak interaction forces compared to the three remaining intermolecular forces, comparing to the ion-ion interaction, to dipole interaction, and of course to the hydrogen bonding. So if you will have this illustration, dispersion forces is also known as London dispersion forces. You have two example of molecules. You have a nonpolar molecule and the dipole molecule. So polarization will happen. So have the dipole and the nonpolar that will be attracted to each other. But remember, so the concept of the polarity of molecules like mixes like. So therefore, it will not attract to each other. Dipole and nonpolar will not attract to each other. Therefore, you need to perform an induced dipole interaction to have a forces binding to each other. So if that will happen, you will have now the London dispersion forces, as you can see here on this illustration. The nonpolar molecule will have an induced dipole for it to become attracted to another dipole. So if this thing occur, this will now called as the London dispersion forces. So what are the impact of these forces to the properties of substances? So I will be specifically stating different properties that we will discuss how intermolecular forces affect to it. Number one, you have surface tension, cohesion and adhesion, viscosity, and of course, evaporation and vaporization. So let's have the first one, surface tension. Surface tension is the phenomenon caused by the intermolecular forces allowing liquid molecules to create a thin film on its surfaces. This is the reason why some organism looks like walking on the surface of the water. Okay? But remember, this is no magic because the science behind of it is the surface tension. So let's give this illustration. So as you can see, this is what is happening during the surface tension or the intermolecular forces interaction with surface tension. So as you can see here, the molecules are attracted to each other. Therefore, they're forming a strong or a weak intermolecular forces. That is the reason why some organism can walk to the water. Number two is cohesion and adhesion. Cohesion is the interaction between same materials, while adhesion is the interaction between different materials. So if we will put an illustration to this one, it will look like this one. Okay, so you have two water molecule 1 and then water molecule 2. If these two water molecule will have an interaction to each other, that is what we call cohesion. But when water molecule is attracted to other material, so on this illustration, as you can see, there is a thread. So if water will attract to the thread, that is what we call now adhesion. This is also very, very common to the water strider that we can observe to the previous presentation. The third property which has been under the influence of intermolecular forces is viscosity. Viscosity is the resistance of liquid to flow. Okay, the stronger the intermolecular forces, the higher its viscosity. So let's give some example. So you have here three substances. You have honey, oil, and water. So as you can see here on this illustration, the ball that been dropped to water go to the bottom, while for oil, it goes to the somewhat near to the surface, while honey is on the middle part. Okay, so this is the molecular structure of honey, as you can see here. Okay, it is somewhat viscous compared to other substance, which is oil and water, because it possesses too many hydrogen bonding, and because of this too many hydrogen bonding, it creates strong intermolecular forces, making it more viscous rather than on the other substances present. Last property under the influence of intermolecular forces is evaporation. Evaporation is the process of turning liquid into gaseous form. So, weaker intermolecular forces equates to greater volatility. It means that if you have weak intermolecular forces, the substance or the molecule will evaporate easily. So, let's give an illustration for this one. As you can see, methane is a good example of intermolecular forces which has affected its property of evaporation or boiling point. So you have here CH4 molecule 1, CH4 molecule 2, and CH4 molecule 3. So all of this CH4 or methane are connected or binded by a weak van der Waals forces or intermolecular forces. Because of this reason, methane exists in gas form rather than on a liquid form. So what is our conclusion now? Our conclusion is that Mother Earth will give you the proper process to form or to destruct its substances. Also remember that whether to like mixes like, you still have opposite attracts. It means that it doesn't matter if you have two same components, okay? Because we still have opposite attracts, even though that we are different to each other, we can still attracted to each other. At the same time, everything will be in balance because of this particular principle. So that's it. I think you are now ready to answer the different activities. So this is the end of the video lesson for week 3. See you next week. Goodbye, class.